Around 30 years ago, we didn't have any proof of planets outside our solar system. But now, because of better technology and more research, we've found over 5,300 exoplanets, strange worlds beyond our own waiting for us to learn more about them. At first, we found mostly big gas planets. But now, as we've gotten better at finding exoplanets, we're discovering smaller ones that are more like Earth. Scientists have found over 50 exoplanets with sizes similar to Earth, and more than 800 that are less than half the size of Earth. We haven't found many planets like Earth orbiting in the habitable zone of their stars yet, where conditions could support life. But things are starting to look up. As we keep searching for habitable planets, we're finding entire systems with more than one planet that might be able to support life. We know about at least one such system nearby in our Milky Way galaxy. There are many small systems here that revolve around stars like our Sun. But the planets close to these stars are usually too hot, which makes them unsuitable for life. When it comes to cooler and dimmer stars, the area where life could exist is closer. One example is Gliese 667, a system with 3 stars located in the Scorpius constellation, about 23 light-years away from Earth. It's the first known system where a small star has multiple rocky planets that might be able to support life orbiting in its habitable zone, similar to Alpha Centauri, which also has 3 stars. GJ 667a is the biggest star in the system, and it's a K-type main sequence star, which means it's orange-red in color. It's a dwarf star with about 73% of the mass and 76% of the radius of our Sun. It's not very bright visually, only about 12% as bright as the Sun. Its companion, GJ 667b, is at an average distance of 12.5 astronomical units. AU, GJ 667b, like GJ 667a, is also an orange-red dwarf of the K-type, but it's a bit smaller, about 69% the mass of the Sun. It's not very bright either, emitting only about 5% of the Sun's visual luminosity. Now, onto the third star, Gliese 667c. It's an M-type red dwarf, much smaller than the Sun, with only about a third of the Sun's mass and radius. Despite being very faint and cold, with a surface temperature of 3,675 Kelvin, GJ 667c surprisingly hosts a rich system of planets. At first, scientists believed there were only 3 planets circling around Gliese 667c. But by looking again at the data they already had and gathering more observations, they found there might actually be 6 planets in the system. Even more exciting, 3 or possibly 4 of these planets could be super-Earths in the habitable zone, where conditions might be right for life. A super-Earth is a planet that's bigger than Earth but smaller than gas giants like Jupiter and Saturn. These planets can be made of rock, or a mix of rock and ice. They might also have atmospheres that could support various forms of life. The closest planet to the star, Gliese 667cb, is a blazing hot world at 200 degrees C. It's the largest planet in the system, about 5.5 times the size of Earth. This exoplanet likely has a very thick atmosphere and orbits its host star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are farther from their host star. They have masses between 1 and 5 times that of Earth, which makes them excellent candidates for habitability. Gliese 667cc, the planet closest to Gliese 667c, sits on the inner edge of the star's habitable zone. It's about 3.8 times the mass and 1.8 times the radius of Earth, with a year lasting just 28 Earth days. With an Earth similarity index of 0.85, it's often referred to as the Holy Grail of exoplanets. Due to the red dwarf GJ 667c's low energy output, its habitable zone is very close to the star, spanning from 0.11 AU to 0.23 AU, which is entirely within the orbit of Mercury in our own solar system. To put it in perspective, Earth is situated approximately 1 AU away from the Sun. If Earth were at that distance from star GJ 1667c, it would be an icy world. However, GJ 1666 orbits its parent star about 8 times closer, at roughly 0.12 AU, completing one orbit around the red dwarf every 28 days. Due to its close proximity to the star, GJ 667c is likely tidally locked, meaning one side of the planet always faces the star while the other remains in perpetual darkness. This setup creates extreme temperature differences between the illuminated and dark sides, which likely have a significant impact on the exoplanet's global climate. Despite receiving about 10% less light than Earth does from the Sun, GJ 667c receives a similar amount of energy because most of the light it gets is in the form of infrared radiation. This similarity in energy input could help maintain water on the planet's surface and potentially lead to a climate similar to Earth's. Since scientists are uncertain about whether Gliese 667cc has an atmosphere and its potential thickness, it's challenging to accurately predict the planet's surface temperature. However, if the planet does possess an atmosphere similar to Earth's, it could distribute heat evenly, resulting in a comfortable temperature of around 30 degrees Celsius on the night side. Living on a planet like GJ 667cc would offer a unique experience. The planet receives a dim reddish light from its star. The other two stars in the system, Gliese 667a and b, are much farther away, about 230 AU, which is greater than the distance between Pluto and the Sun, and they lie outside the planetary system. Despite their distance, the other two suns would still appear as a pair of bright stars during the day on GJ 667cc. At night, they would shine as brightly as the full moon, while our sun would seem like a distant star. However, the nearby red dwarf is known for emitting flares or intense bursts of radiation and energetic particles, which can be up to 1,000 times stronger than the flares on our sun. This situation could pose challenges for any potential life on Gliese 667cc's surface because the planet is situated near its flaring host star. Additionally, the strong magnetism of the red dwarf might lead to star spots, which can decrease the star's energy output by up to 40% for extended periods. Coupled with the lack of ultraviolet light emissions, this could further hinder the formation of life as we understand it. Living on Gliese 667c would indeed be quite different from what we're accustomed to, partly due to its considerable mass. Because it's a rocky planet, the gravitational acceleration on its surface could be up to 60% stronger than what we experience on Earth. This would significantly affect how objects behave and how creatures move around on the planet. Exactly. On Gliese 667cc, a person weighing 75 kilos on Earth would weigh approximately 120 kilos due to the stronger gravitational pull. Furthermore, because a planet with greater mass can retain a denser atmosphere, the atmospheric pressure at the surface of Gliese 667c would likely be higher compared to Earth, which would also impact living conditions and environmental factors. Correct. If Gliese 667cc possesses an atmosphere similar to Earth's, the atmospheric pressure would only be a few times higher, which might be manageable for certain life forms. However, if the exoplanet has a Venus-like atmosphere, the pressure could be several hundred times greater, akin to the immense pressure experienced several kilometers deep in Earth's oceans. This significant atmospheric pressure difference would have profound implications for the planet's habitability and the potential for life as we know it. Indeed, while Gliese 667cc is situated in a habitable zone, it may not offer the same conditions as Earth. Life forms on Gliese 667c would likely need to adapt to various challenges such as fluctuating and lower light levels, potentially high atmospheric pressure, and frequent solar flares from its host star. Adapting to these conditions would be crucial for any potential life to thrive on this exoplanet. You're absolutely right. While the conditions on Gliese 667cc may pose challenges for life as we know it, it doesn't rule out the possibility of life forming on such a world. Earth itself shows remarkable adaptability of life forms to diverse environments, including extreme conditions. As for Gliese 667c and Gliese 667c, Being located farther from their star means they receive less energy. However, their similarity to Gliese 667cc suggests they could also harbor potential for habitability, albeit with different environmental conditions. Further exploration and study of these planets could provide valuable insights into the potential for life beyond our solar system.